When we come to the scientific evidence, which we're going to examine now in some detail, we actually find that most methods that have been used by scientists to date the world give a young age. It's been estimated about 90% of them give a young age. So guess which ones they focus on the most? The 10%. Why? Well, it's obviously they require the millions of years for their evolutionary story, their evolutionary creation myth, because that's what it is. Without the millions of years, there's no time for evolution. It wouldn't even get out of the starting blocks. By the way, even with billions of years, it can't get out of the starting blocks. But that's another story. But they focus on the methods that give them the answers they want. And so we need to deal with those very carefully.
Well, let's talk about geology now, the study of rocks, and we'll include fossils in this as well. The first misimpression that I have to clear up here, because people think, well, haven't rocks been radiometrically proven to be billions of years old, right? And people have misconceptions about that. They just think it's almost like magic. You know, you take up your rock, you hold your tricorder out, you scan it, and there it is, millions of years old, right? Well, really, it's more complicated than that. I'm going to kind of sum it up here for you briefly. It's again more complicated than this, but basically there are certain kinds of atoms in nature that are unstable. We call them, they're said to be radioactive. And what that means is they will spontaneously change into another type of atom. You don't have to, there's no external force necessary. Uranium-238, for example, will spontaneously change into the next atom, which changes into the next one, and so on, all the way down to lead-206. Lead-206 is not radioactive, it's stable, and so once you're lead-206 forever, you are lead-206, unless there's some kind of outside force. But fortunately, only a small fraction of atoms are of the radioactive variety, so you don't have to worry about changing into something else within the next 24 hours anyway. Now, the idea is this process, at least for some atoms like uranium, is very, very slow. Atom by atom, one popping into the next and so on. And so the idea is if you had a chunk of solid uranium and you waited long enough, it would be part uranium and part lead with some of the intermediate elements as well. And eventually it would be all lead. That's the idea. And so you can use that like a clock because the rate is known. And it's thought not to be affected by temperature, at least not very much, or by chemistry and so on. And so it seems like it's a really good clock. And so if you pick up a rock on Earth and it's got some uranium and some lead in it, you could extrapolate backwards and figure out when the rock was all uranium. But how do you know it was all uranium to begin with? Maybe the rock had some lead in it to begin with when it was first created, right? So you'd have to know what it started with, right? Well, how do I know what it started with? Well, you tell me how old you want the rock to be, and I'll tell you what it started with. You see? And by the way, evolutionists do not assume that it started with all uranium. They assume that it had some lead in it to begin with. In a way, it's the same way that you can keep time with an hourglass. Now, I think you can keep time with an hourglass if certain assumptions are met. I mean, if you came in here and I had an hourglass, starting when you first came in here and it looked like that, it looked like it does on the screen with about halfway through, and I say, how long ago did I turn that over? That's easy. It's an hourglass, halfway done, half an hour, right? I say, oh, I got you, because in fact it was sideways when I first came in. Already a lot of the sand was in the bottom chamber. You see, you assumed that all the sand started in the top chamber, which would be like assuming the rock was all uranium to begin with, and that wasn't the case. Or how do you know that somebody didn't come and add sand to the hourglass when you weren't looking, right? That would affect your age estimate. And in fact, in rocks, certain chemicals like uranium are leachable in salt water. They can actually move in and out of the rock. It's possible for that to happen. Or how do you know the throat of the bottle has always been the same size? Even if the throat was wide, it's probably realistic for an hourglass. But we think that the rate at which radioactivity occurs can change. We know it can change under certain circumstances because we can do it. Certain kinds of radioactivity have been accelerated by a factor of 1 billion in laboratories. And so if it can happen in laboratories, it can probably happen outside of laboratories too. So basically, these are some of the assumptions involved in radiometric dating. That the initial conditions are known, that the decay rate is constant. We have very good evidence that number 2 is wrong. And for that reason, the estimated ages of these rocks are going to be very much inflated because they assume that the decay rate's been constant when in fact it hasn't. But regardless of these details, I want you to take home this bottom line. Here's the bottom line. We've tested rocks of known age, and they fail in terms of getting the right radiometric age estimate. Mount St. Helens, for example, when it erupted in 1980 and there were some subsequent eruptions, we took some brand new rocks that had formed from the magma, and that's supposed to set the 0 point for the radiometric clocks. And we sent them in and had them radiometrically dated, which you normally wouldn't do because it's expensive. Why would you test it on a rock of known age, right? Well, because we wanted to check the method. We wanted to see if the method works. And these brand new rocks came back with estimated ages of hundreds of thousands to millions of years on brand new rocks. And you say, well, that's an isolated incident. It's not. If you go to Hawaii and you take a rock from Hawaii and have it radiometrically dated, a brand new rock, you saw it come out of the volcano, you could stick your pike in it and let it cool right there and send it in, you will get millions of years, pretty consistently. So the bottom line is radiometric dating has been shown to not work on rocks of known age, and yet evolutionists assume it works on rocks of unknown age. Now, to me, that's a lot of blind faith right there. That's not a reasonable faith. We all have faith. That's not a reasonable faith. Because when you test it and it doesn't work in little things, how can you trust it in large things? That's kind of a biblical principle, isn't it? If I gave you a calculator and you put 2 plus 2 equals, and it gave you 67,521, and I said, well, no, don't worry, it works on big numbers. So I don't think I trust that. I don't think I would trust it with big numbers. What about carbon dating? Now, carbon dating is a little better because we think the acceleration of the radioactive decay didn't affect carbon as much. But people have heard of carbon dating. They think it gives billions of years. It doesn't, nor could it, because C14 decays very quickly. I'll come back to that. But carbon dating is one type of this radiometric dating. But with carbon dating, it tends to give the right answer. And when we test it on things of known age, it tends to give reasonable answers. Now, it's not infallible either, but it tends to give answers that are consistent with what we'd expect when tested on things of known age. And the idea with carbon dating is there's a certain variety of carbon. Most carbon is C12. There's a certain variety of it that's C14. It's got 2 extra neutrons, and it's radioactive. C12 is stable. C14, radioactive. And a small fraction of that is in the atmosphere that we're breathing right now. It's in the food that you eat. It's incorporated into your body. So a small fraction of you is C14. So you're all slightly unstable. How about that? You knew that, though, right? And while you're alive, I mean, that C14 is constantly decaying into nitrogen, but when you're alive, you're replacing it because you're eating new food, you're breathing air, and so on. You're exchanging carbon with your environment, and so you replenish it. But when you die, it simply decays away. And so the idea is by measuring the C14 to C12 in something, you can tell how long ago it died. And we find that it tends to give the right answer. And the interesting thing is it gives the right answer that creationists would expect, even on things that evolutionists believe to be millions of years old, like coal beds. You can take a chunk of coal, it'll have C14 in it. Every time. You won't find an exception to that. And yet if if the entire Earth were nothing but C14, after 1 million years, you would not have a single atom left. That's how quickly it decays. And yet they find it in coal beds that they think are hundreds of millions of years old. Can't be that old. The C14 would be gone. We've even found C14 in diamonds. Diamonds that evolutionists believe to be 1 to 2 billion years old based on these other radiometric methods. And yet there's C14 in them. They can't be that old. They can't be more than a few thousand years old. Isn't that interesting? And they say, well, there must be some kind of contamination. How? It's a diamond. It's the hardest substance. How are you going to get new C14 in there? It doesn't make any sense. We've even carbon-dated dinosaur fossils. You know, sometimes with fossils, if there's enough carbon left, you can actually carbon date them. And every one that we've tested has C14 in it. They're all thousands of years old. Not one of them is dated millions of years old by carbon dating. Lots of things like that. You tend not to hear about these in the secular school system, sadly. But there are all kinds of physical processes that limit the age of the Earth to much less than the billions of years that most people are taught. The rate, for example, at which salt goes into the ocean. You know, even freshwater rivers have a little bit of salt in them. They pick it up from the continents. They dump it into the ocean. The water evaporates, but it leaves the salt. And so oceans are consistently getting saltier and saltier. You can get rid of a little bit of the salt with salt sprays and things like that. But essentially, 450 million tons of new salt enters the ocean every year. The oceans are getting saltier. Now, you can work the math backwards, and even being very generous to the critics and assuming the slowest possible conditions, the oceans can't be more than 62 million years old, because at that point, that's an upper limit, right? Because you can't have less salt than no salt. So that's assuming they had none to begin with. Obviously, if the oceans started salty, then they're much younger than that. So that's a problem, though, for the secularists, because they believe the oceans are 3 billion years old, but they can't even be anywhere close to that. On the other hand, it's perfectly compatible with 6,000 years, because it's an upper limit. 62 million as an upper limit would include 6,000 years as a medium or lower limit, and then the secular age is way off. Likewise, for the accumulation of mud on the ocean floor, you measure the amount of mud that's there, you measure the rate at which it accumulates, you find it takes less than 12 million years at present rates. And that assumes there was no worldwide flood, which would dump mud on the ocean floor very quickly. And so that's consistent with the biblical time scale, but it's not consistent with the billions of years. Lots of things like that. Human population. How long does it take to get Earth's current population of human beings from just 2? It doesn't take anywhere close to millions of years. Not anywhere close. It takes a few thousand years, something like 4,000 years, because the human race had to start over with Noah and his family. So it's very consistent with that. World population growth, we've been able to measure that to some extent over the centuries. The best evidence, though, that the world's thousands of years old, not millions or billions, because all of these are circumstantial. They're good, but they're circumstantial. We only have one that's definitive. We have the testimony of the one who created the heavens and the earth. And he tells us when he made it. He tells us he made it in 6 days, and he tells us from those genealogies you love to read before you go to bed, and so begets so-and-so. You add up those ages, and you find it was a few thousand years ago that God created the heaven and earth and all that's in them. And that's very clear. The science lines up with it, but the Bible's very clear. So the secular scientists say the earth's billions of years old, take my word for it. God says I created in 6 days, take my word for it. And by the way, it's not because of the evidence that evolutionists believe in millions of years. It isn't, because we've seen the evidence really is very consistent with biblical creation. They have a philosophy that drives them to interpret the evidence that way. Now, we all have a philosophy. We all interpret the evidence in light of our philosophy. It's just mine works. Mine is self-consistent because I base mine on Scripture. What about fossils? I was sort of given the impression that fossils take millions of years to form. Well, here you have a fossil ichthyosaur, a marine reptile now thought to be extinct. And this thing was fossilized, killed, and buried and fossilized in the process of giving birth. You see the baby ichthyosaur being born there? They were born tail first because they had to swim to the surface to get their first breath of air. As air breathers, really fascinating. You have there a fish fossilized in the process of eating another fish. So again, I don't think that's taken millions of years. Obviously, the thing was killed and buried quickly at least, and then it must have fossilized relatively quickly. You can even see some of the stomach contents from the ichthyosaur. See, people think that, something dies and then just slowly fossilizes. Most things don't fossilize at all. And we sort of know that from experience, right? I've been picking on dogs. Let's pick on cats now, okay? Let's suppose that we're going to do a little experiment here on our dead cat, Earl. And day 1, dead cat on grass, and we got the sign there, so nobody's going to touch it, all right? Day 3, wait a little while. Now you got a smelly dead cat on the grass. Day 9, very smelly dead cat on the grass. Day 20, parts of Earl missing. Day 38, more of Earl missing. Day 65, Earl's missing. Yes, okay. Things don't just slowly fossilize over millions of years when they're exposed to the environment like that. They decay. They're recycled back into the environment. They're picked off by scavengers and what have you. Things don't just slowly fossilize over millions of years. You have to bury something to get it to fossilize, really, to protect it. You have to do something to protect it, and burying is usually the way to go. But even there, I was given the wrong impression. I was told that the fish dies, it sinks down to the bottom, it's slowly covered with sediment over millions of years. But you see, if this layer was deposited, or this layer was deposited millions of years after that layer, the top of the fish would have decayed already. The whole thing has to be buried pretty quick. Fish tend to float anyway, right? Or they're picked off by scavengers, and they don't just sink to the bottom and wait to be fossilized. It doesn't happen. Now, if you really want to form a fossil fish, here's how you do it. You go home to your aquarium, and you dump some concrete on your fish. There you go. That's going to kill him. It's going to bury him, and he's going to fossilize. All right, as long as the minerals moving through there are right, he will permineralize. That's what a fossil is. It's the minerals moving through and filling in all the little holes in the bone. Usually the flesh has time to decay away, but the bone gets permineralized. And so that's how you make a fossil. It doesn't take long times. It just takes the right conditions. And we can fossilize things quickly in a laboratory. It doesn't take a long time. What about the types of fossils we find? We find fossils of fish and horses and people and so on, but we don't find one kind changing into another. And so when you see things like this in the textbook, the evolution of the horse, and you say, boy, there are a lot of different varieties of horse there, right? That's what I'd expect in the creation view. Now, they can line them up, right? But you can line up a fork and a spork and a spoon. But that doesn't mean that one changed into the other, right? I mean, just because there's a sequence doesn't mean it's an evolutionary sequence. These are just different varieties of horse. And the number of ribs is different, and the feet are a little different. And you say, oh, but yeah, but one of them is really big and one of them is really small. So what? We have different breeds of horse today. These are both adult horses. They're just different breeds. A lot of variation within a kind. That's exactly what I'd expect given biblical creation. The kinds of fossils that we find are exactly what we'd expect given the variation within the kind that the Bible teaches. What about the rocks in which these fossils are found? Don't rocks take millions of years to form? Not at all. Here's a set of car keys embedded inside solid rock. I don't think that took millions of years to form. Unless cars go back a lot more than I think they do. Here's a man-made clock embedded inside solid rock. How about that? I don't think that took millions of years. Well, surely all these layers of rock shown here took millions of years. There's a person down there at the bottom for scale. See that? Those layers did not exist before 1980. Those were all produced in the Mount St. Helens eruptions. Isn't that interesting? And they're solid rock now. They were formed by a pyroclastic flow that came out of that volcano. And Mount St. Helens was a small volcano by volcano standards, really. The Bible says that during the Great Flood, all the fountains of the Great Deep burst forth. That might indicate all the volcanoes on Earth going off, something like that. So, and it carved out the Mount St. Helens eruption carved out a canyon, 1/40th the scale of the Grand Canyon. It did this in days. It doesn't take millions of years for these things to happen. It happens quickly under the right circumstances. So you see, when we take a look at geology and we see how these rock layers form today, and we see how they can form under catastrophic conditions, we find that it's really very consistent with what we'd expect from Genesis. And so I want to now talk about a couple of issues where the secular experts today have not quite caught up to the truth of the Bible. One of those deals with the age of the universe. And my secular colleagues would say, no, 13.8 billion years for the age of the universe, and Earth's 4.5 billion years old. Well, the Bible indicates that's not the case. It indicates a much younger universe, a much younger Earth. And I want to show you that even today, there is evidence that lines up with what the Bible teaches about the age of the universe. Scripture teaches a young universe. It's clear that God created in 6 days, and it tells us what he did on each of those days. It's clear from context. Those are ordinary days because they're bound by an evening and a morning. Some people have tried to stretch that out into ages, but that won't work in the Hebrew based on the context. Because you're bound by evening and morning, and there's a number with them and so on. Human beings are made on the 6th day, and from those genealogies you love to read before you go to bed, and so-and-so begets so-and-so, you can add up those ages, and it's no harder than balancing your checkbook, and it's a few thousand years. And the universe, by the way, that most of the celestial objects in the universe are made on day 4, and so that pins the universe at a few thousand years as well. That goes against what I was taught. I went through the secular school system, and I was taught billions of years, but there's evidence that confirms thousands of years. For example, the excess internal heat of the giant planets. Jupiter gives off twice as much energy as it receives from the sun. Okay, it's actually, it gets some energy from the sun, but it gives away twice as much. Okay, and you can't keep doing that forever, right? Because it's losing energy. You can't continue to spend away, more than you take in, unless you're the federal government, right? Well, Jupiter's losing energy, and it can't do that forever. The federal government can't do that forever either, by the way. Anyway, it's kind of like when you take a potato out of the microwave. It's nice and warm, and it radiates that heat out into space, right? But it can't do that forever because it's only got so much energy. It cools off. And for a potato, it doesn't take that long. Now, Jupiter is a much bigger potato. It's 10 Earths across, and so a few thousand years, it's not going to cool off very much. But if it were billions of years old, why isn't it an icicle by now? That's a problem for the secular view. The problem's even worse for Neptune, which gives off 2.7 times as much heat as it receives from the sun. Why is it so relatively warm if it's really billions of years old? And that's a perplexing dilemma for the secularists, but it makes sense given that they're young. These worlds are thousands of years old. The Earth's magnetic field. The Earth has a magnetic field that's caused by electrical current in the core, and that makes that magnetic field that surrounds us like a blanket, protects us from solar radiation and cosmic radiation and so on. And of course, you can make a magnet by taking a coil of wire and wrapping around, touching it to a battery. That's electrical current causes magnetism. And just like a battery runs down, Earth's magnetic field is running down. Earth's magnetic field is actually decaying. And we've been able to measure that over the centuries. And it's been decaying in a steady exponential decay. Now, we think during the flood year, because of all the tectonic activity, that would have disrupted those currents, and you'd have rapid oscillations in the field strength. But the total energy is just going to drop. So in terms of the total energy, it's just been dropping since creation. And we can measure that. We know from the last almost 2 centuries, we can measure the drop in the magnetic field. It's quite consistent with that exponential decay. It's exactly what we'd expect, which means you run it backwards, and at creation, it was a bit stronger than it is today. But you run it back 1,000,000 years, and it gets so strong, it rips the iron out of your blood. And that's not good. It would actually make life impossible if the magnetic field is as strong as would be required if it was even millions of years old, let alone billions. And so it's a big problem. My secular colleagues have to believe that it doesn't have this exponential decay, but that it's constantly oscillating back and forth, but there really isn't evidence for that today. Again, there might have been temporary oscillations during the flood year, but that just drains the energy even faster. It's not just Earth, but a lot of the other planets of the solar system also have these magnetic fields. Jupiter's would be bigger than the sun if you could see it. It's a very powerful magnetic field. And why is it still so strong if the planet's billions of years old? And I'm going to suggest it's because the planet's not billions of years old. It's thousands of years old. So it hasn't had time to decay yet. The planet Uranus. Uranus is tilted on its side as it orbits the sun, so it rolls around the sun. It's one way to think about it. And the magnetic field axis is stuck in the side like a bar magnet. It's not even lined up with the rotation axis, so the magnetic field would wobble as the planet rotates. Really strange. So the planet Uranus is just really messed up on a number of levels. And I think God did that just out of his creative diversity. But the magnetic field, I want to point out, the magnetic field is quite strong on the planet Uranus. In fact, it's strong enough you can have aurora borealis, northern lights. We have northern lights from time to time when Earth's magnetic field gets disrupted by solar radiation, and that's because of Earth's magnetic field. Well, that's northern lights. That little spot you see there on the bottom, that's not photoshopped. That's an actual image of northern lights on the planet Uranus. How about that? And it's much further away from the sun than we are. So that shows you the magnetic field has to be pretty substantial. And in fact, the Voyager 2 spacecraft, when it flew past the planets Uranus and Neptune, it measured their magnetic field and confirmed that it's consistent with thousands of years of decay. Isn't that interesting? My colleague, Dr. Russ Humphreys, who used to work for us at ICR, he's retired now, but he actually predicted the magnetic fields of Uranus and Neptune before they were measured by the Voyager 2 spacecraft. And he based that on their age of 6,000 years. He said, okay, based on 6,000 years of decay, here's what the magnetic field should be. The evolutionists thought that those planets are billions of years old, and so they thought the magnetic field should be virtually non-existent. Voyager 2 measured it. It was perfectly consistent with creation. How about that? Consistent with 6,000 years. That's real science right there. If you want to get the correct answer, you better start with the truth of God's Word, rather than ignoring that history and relying on guesswork instead. My secular colleagues, perplexed by that, have said, well, there must be some kind of recharging mechanism that builds up the magnetic fields again. And if you've heard of magnetic dynamos, that's what magnetic dynamo models are. And they have problems of their own. One of them is that in the magnetic dynamo model, the rotation axis should be aligned with the magnetic axis. Is it? Not even close. Not even close. And they said, well, maybe that's just an anomaly. But when they flew past Neptune and it was doing the same thing, that kind of blew away that hypothesis. No, it's just consistent with thousands of years. Do you know the moon is actually moving away from the Earth? It's actually, and the reason it does that, the moon induces tidal bulges on the Earth. It pulls on the Earth's oceans, and that causes these tidal bulges. The tidal bulges get ahead of the moon because the Earth rotates faster than the moon orbits, and so the tidal bulges are always a little bit ahead of the moon, and they pull forward on it. And the counterintuitive thing is when you pull forward on something in orbit, it moves out. When the astronauts want to go into a higher orbit, they thrust forward, and that moves them out. It's a little bit strange, but if you've ever played with a gyroscope, you know that when things are spinning, they don't always act the way that your intuition would expect. But the moon is moving away at about 1.5 inches a year, so it's not a huge rate. If you run it backwards, that means 6,000 years ago, it would have been something like 730 feet closer to Earth. Not a big deal, considering the moon is 248,000 miles away. What's 730 feet among friends, right? But if you run it back billions of years, you got a problem. And you have to do the math right on this, by the way, because if you're running the movie backwards, as the moon gets closer, the tidal bulges get bigger, and it gets closer, and they get bigger, and it gets faster, you see. And it dives in at 1.4 to 1.5 billion years. So the Earth and moon would have been in the same place at the same time, and that's not good. And that happens at 1.4 billion years. And that may sound like a lot, but my secular colleagues believe the Earth and moon to be 4.5 billion years old. But they can't be older than 1.4 or 1.5 based on the recession rate. So it's just an indication that their worldview isn't correct. It doesn't make sense of the evidence. Comets are made up of icy material, and they orbit the sun in elliptical paths. They tend to go very far away from the sun, and then they come close and they whiplash back out. And when they're far away from the sun, their icy material remains icy material. When they come close to the sun, ice close to the sun, that can't be good. That icy material is blasted away from the nucleus of the comet. It's vaporized. And that's actually what forms a comet's tail. That's dust and other material and ice being blasted away by solar heat and radiation. So every time you see a comet, it's getting smaller. And by the way, that's why the tail always points away from the sun, regardless of what direction the comet's moving. I don't know which way this one's going. It might be going that way. Who knows? But the tail always points away from the sun for that reason. Every time you see a comet, it's getting smaller. It's losing mass. And it can't do that forever because it has no source of new mass. So it just gets evaporated away. And we estimate that a typical comet can last no longer than 100,000 years maximum. And some of them much less than that. I used the SOHO spacecraft in my doctoral dissertation. And one of the things it can do is it's designed to look at the sun. And one of the things it can do is it can block the actual sun and look at the outer atmosphere of the sun, the corona. And because of that, it's very good at spotting comets. Because comets get really bright when they get close to the sun. Hard for us to see them because of the solar glare. But SOHO is designed for that. And so SOHO has discovered over 1,000 comets. And I've seen them because I've used the spacecraft in my research. And I've seen comets that have gone behind the sun, and that's it. They're totally obliterated in one pass. They don't even survive. Interesting. So I know that they're short-lived. They can't last millions of years, let alone billions of years. Now, my secular colleagues believe the solar system's 4.5 billion years old. So why do we still have comets? It's kind of like if you walked into a sauna, nice and warm, and you see some ice cream cones there just starting to melt. You know they haven't been there very long, right? Comets are sort of the ice cream cones of the solar system. They are an indication of its youth. And by the way, my secular colleagues, they know that. They can do the same math I can do. They can calculate the rate at which the material is leaving, and we know the amount of material that's there in the nucleus. They know that comets can't last long. And so they figure there must be somewhere out there a comet generator that makes new ones, which they call the Oort cloud. If you've ever heard of the Oort cloud, that is an invented idea to try and explain why we still have comets in a solar system that's supposedly billions of years old. And the idea is there's this vast reservoir of potential comets out there orbiting way beyond where we can detect them. And every now and then one of them is thrown into the inner solar system, becomes a brand new comet. Pretty clever. There's no evidence of an Oort cloud, though. The only place you'll find it is in textbooks, but you won't find it in the actual universe. Not yet, anyway. My secular colleagues have a lot of faith in these kinds of things. Spiral galaxies. Now, not all galaxies are spiral. Some have more of an elliptical shape, but a lot of them are spiral. And these spiral arms rotate differentially, which means the inner portions rotate fast, as indicated by the arrows. The outer portions rotate slower. And so what you would think then is the galaxy would have to be twisting itself up. It's winding itself up tighter and tighter. That spiral structure would have to get tighter every rotation. And it turns out in 6,000 years, it hasn't rotated even once, and so it's not a problem. In fact, in these barred spiral galaxies, you can still have that bar structure there. It's just starting to wrap up a little bit in the middle there. In 6,000 years, not a problem. But if these galaxies are billions of years old, it'd be a huge problem because they'd be twisted beyond recognition. I recently wrote a computer simulation to use the actual velocities that we've measured in these galaxies to simulate what they would look like in 1 billion years. They're totally unrecognizable. You would not see that spiral structure. They look more like a, I'll have to show a picture of it at some point. I'll show you the results of the simulation, but it's really interesting. They wouldn't look anything like this. This looks like a young galaxy, and the interesting thing is all the spiral galaxies look kind of like that one. They have very distinct spiral arms. They don't have that real tight spiral structure that you would expect if they were really 10 billion years old. In fact, even after 1 billion years, you can't have spiral arms anymore, and they're supposed to be 10 billion years old. It doesn't work. And so my secular colleagues have to figure out ways to make new spiral arms as the old ones are wrapped up beyond recognition, spiral density waves and whatnot. But it's just easier to believe that the galaxies are the age the Bible indicates. That makes sense of their structure. You might notice, too, that these spiral arms have kind of a bluish tinge to them. That's because they have a higher proportion of blue stars relative to the central bulge. And blue stars themselves are an evidence of the youth of the universe, because blue stars cannot last very long. They expend their fuel quickly. Blue stars are the most massive, most luminous, the brightest stars out there. And because they're giving out their energy so quickly, they're spending it like crazy, they can't last very long. They run out of fuel very, very fast. Now, they have the most fuel, right, because they have the most mass, but they expend it even quicker. They're kind of like the SUV of the star world. They have a big tank, but they get very poor gas mileage, and so they can't go very far. They can't last very long. The hottest, brightest blue stars can't last more than about 1 million years, and yet we find blue stars all over the universe. All over the universe. They're there. And my secular colleagues have to believe that, well, they obviously have formed there recently, but no one's ever seen a star form anywhere. Oh, you'll read about it in the newspaper. You know, they'll call this a star-forming region. Well, let me clue you in. What they're doing, they're not seeing stars form there. What they're finding there are blue stars that they know can't be billions of years old. And because they can't accept a recent creation, they have to say, well, apparently stars have formed there very recently, and so it must be a star-forming region. But nobody's actually seen a star form. And I think there are some very serious physics problems getting a star to form from a nebula. The idea is these nebulas collapse in on themselves, but gas normally doesn't collapse in on itself. Gas normally fills the container, right? When you walked into this room, you didn't hold your breath just in case all the air should go to that corner. You expected it to spread out. And aren't you glad that it did? Gas tends to do that. Gas pressure tends to be a lot more substantial in space than gravity. Now, once you make a star, its own gravity will keep it there because the gravity overcomes the gas pressure. But getting it to that state is a challenge, and it may even be impossible. So these are all just indications that the universe really is the age that the Bible says. And there are a lot more, but those are the ones that I think are some of the better arguments for which the secularists don't really have a good counter-argument.
Now, I think these are amazing lines of evidence, don't you? I mean, they're pretty powerful confirmations of biblical creation, but they really don't constitute an ultimate proof. I mean, it may seem like I've refuted the evolutionary worldview, that I've absolutely demonstrated creation, but I haven't. And the reason is, for every one of these lines of evidence that I've presented to you, an evolutionist can always come up with what we might call a rescuing device. He can come up with a conjecture designed to protect his worldview from what appears to be contrary evidence. So in the case of comets, for example, my secular astronomy friends, they know that comets don't last that long. But they say, well, we know the solar system is billions of years old, so there must be some source of new comets, which they call an Oort cloud after its inventor, Jan Oort. And so the idea is there's this vast sphere of potential comets way beyond the planets, beyond where we can detect it. And every now and then, one of these is thrown into the inner solar system and becomes a brand new comet. So as the old ones are depleted, new ones replace them. That's kind of convenient. So you see the solar system can be billions of years old after all. Now, if I were to ask a secular astronomer, do you have any observational evidence of an Oort cloud? If he's honest, he'll say, well, no, but you can't prove it's not there, right? And that's true. I can't prove that there's not an Oort cloud. It's very hard to disprove something that can't be detected in any way. So yeah, I mean, that's true. And therefore, there could be an Oort cloud. And therefore, comets don't prove that the solar system's thousands of years old. They confirm it, but they don't prove it. And if you think about it, an evolutionist can always invoke a rescuing device because there are always unknowns. We don't know everything. And there are always unknowns in science, and therefore the evolutionists can always invoke a rescuing device. And by the way, so can you. I might ask you a question that you don't immediately know the answer to. You'll come up with a rescuing device. You're not ready to just give up your worldview on the basis of one little unsolved mystery there. And so I can't really blame my evolutionary colleagues for inventing the rescuing devices. I'm not blaming the secular astronomer necessarily for thinking there's an Oort cloud. That is consistent with his observation that there are comets and his worldview, his belief that the solar system is billions of years old. So he's thinking in a way that is consistent with his worldview. On the other hand, I don't necessarily believe in an Oort cloud. I don't have any reason to. I look at comets and I say, yeah, that's what I'd expect. Because I start with a different worldview, a different way of thinking about things. If you think about it, creationists and evolutionists really all have the same facts, don't we? I mean, I have access to the same DNA patterns, I have access to the same fossils, the same stars and galaxies as my evolutionary colleagues. We have the same facts, the same physical evidence, as it were. We have the same science. I use physics and chemistry and astronomy. My secular colleagues use physics, chemistry, and astronomy. We have the same science. Why then do we draw such different conclusions about the past? And the answer is we have a different starting point, a different worldview, a different way of thinking about things, which you can liken into mental glasses. Those of you that wear glasses, you know that if you have those off, the world looks fuzzy. You put those glasses on, the world snaps into focus, and you see things as they are. And I like to think of the Bible like corrective lenses. You think about things from the perspective of biblical history, you see the world as it is. I like to think of evolution like red glasses. You put on red glasses, the world looks red. Not that the world is red, but that's what you see, because you see it's biased because of the glasses you're wearing. Now, I realize, of course, evolutionists will say, oh no, we're the ones wearing the corrective lenses, you're the ones wearing the red glasses, and we're going to have to argue for that. My point here is simply that we all wear mental glasses. We all have a worldview. We all come to the evidence with certain preconceptions, with certain beliefs about how that evidence should be interpreted.